full disclosure for those that are going to be looking at this on the South by Texas State website, I have worked with Tony, and Tony has worked with me this past fall. So there is no journalistic malpractice here. You all know that we have worked together. As you can see, I'm sporting my NASA Goddard Hubble 25th shirt, and that's the project that we worked together on. So now you all know.
Yeah, so if you're following the at NASA Hubble Twitter account over from January to, I guess, through April, there's going to be all the tweets that come. Most of the tweets that come from that account will be written by Carl. Will have been written by him.
So there you go. So you do social media at the Space Telescope Science Institute, and you're going to be coming down to South by over the spring break. And I was wondering, so what is the Space Telescope Science Institute, and how are you guys going to be involved at South by Southwest?
So the Space Telescope Science Institute is a contractor for NASA. We've been contracted to both operate the daily operations of the Hubble Space Telescope are our responsibility, making sure the observations get made, making sure that the telescope is operating nominally. And they also decide who gets to use it. They have something called a time allocation committee that meets every year. People put in proposals saying what they want to use Hubble for, and then the scientists or the time allocation committee review each and every proposal, and they look to decide which one it would be the best use of Hubble, and they select those proposals based on that. There's always a lot of competition, obviously, for using the Hubble Space Telescope, so it's a very grueling process. That happens every year. And finally, we have a building full of astronomers who are doing science themselves with the Hubble Space Telescope. So we're involved in all aspects of Hubble. We also do and are responsible for the archiving and serving of Kepler data. We're also being involved in the brand new WFIRST mission, which is being still in the planning stages now. That's a new sort of second generation successor to the Hubble Space Telescope. It's called the Wide Field Infrared Survey Telescope. And finally, we're also heavily involved, obviously, with the planning of JWST, because we're going to be contracted to operate the James Webb Space Telescope when it launches in 2018. So that's what the Space Telescope Science Institute does. And so as far as South by Southwest, we've been going for the past, I guess this will be our third year. We went 2 years ago for the first time, where Northrop Grumman, the contractor for James Webb Space Telescope, they're building the main components of Webb, built this full-scale model of the Webb Space Telescope, and they put it out in front of the interactive pavilion there in Austin. And we built an entire exhibit around that. It was all free because NASA's a government agency. It can't charge for what it does. And so everything we did there was free. We had a giant pavilion. Everybody came. We did social media things. We did some live streaming. We even broke a Guinness World Record that year for the largest astronomy lesson ever given, which it's a very arcane category, I suppose. But but we broke it. It was weird. And then last year we did things were scaled back considerably. We didn't have the full size scale model. We just had an exhibit in the gaming expo, and we just talked to people about the Webb Space Telescope and Hubble. And this year we're going to be part of NASA's booth, and because this is the 25th anniversary of the Hubble Space Telescope, it's been up for 25 years, folks. That's the longest any space mission has been running. And so the manned spaceflight program of the shuttle, there's no way Hubble would be up there 25 years. I mean, we all remember well, maybe you're too young to remember, but when it first launched in 1990, it had problems, had to be fixed almost right away. And so it's been fixed 4 times. It's had 4 different servicing missions. And every time that people, astronauts, have gone up there, they've made it a brand new telescope every single time. And this last time they went up in 2009, they did it again, and they replaced gyros, they replaced cameras, they replaced all kinds of components to keep it up there. The idea is to keep Hubble alive until after James Webb launches, and even into some operational overlap, so that we can have both telescopes providing data at the same time. And so far, Hubble's on track to do that.
Yeah, that's going to be really, really great, because being able to measure the near-infrared stuff that Hubble can do, along with the near-infrared stuff that Webb is going to be able to do, is going to be able to help us really calibrate Webb a whole lot faster and get way more accurate data and understand the stuff that Webb's going to get that Hubble can't get way better.
That's true.
So
that's very true.
Yeah. It's not going to be so much a marathon handing off the baton, a relay race. They're going to run side by side for a little while on the same team, which is going to be really, really, really great.
Right. And the ultimate downfall of Hubble, if we don't do anything about it at all, we don't send up robotic craft or anything else to go grab it or push it up higher, it'll decay. Its orbit will decay catastrophically in 2025. So if we don't do anything, we've got until it'll be up there. That'll be the limiting factor for how long it stays up.
It'd be nice if we could reboost it a little bit higher, or create some robot that could encase it in a heat shield and bring it home and stick it in the Smithsonian or something.
Oh, I totally agree.
Or at the very least, some small engine that could dock with it and just give it a little boost. So whenever we build our space hotels 50 years in the future or something like that, someone could go and visit it and be like, oh, look, there's John Grunsfeld's glove prints.
Well, that's what I'd like to see. I'd like to see us keep pushing it out in orbit indefinitely. And I always imagine that sooner or later it would turn into this orbital national park, right? Where, this is the Hubble Space Telescope National Park or something, up in orbit, where it becomes some kind of, heritage site or something like that.
See, that's the problem though. Back during the space race, I forget what it was called, but it's colloquially called the Space Treaty, but it says that no nation can claim sovereignty over an area of space or any celestial body. Now,
I know.
We own the Hubble. We own the Hubble, but the area that it's at, we don't own. So creating a national park would be. But once we have this capability, if we keep on reboosting it or put an ion drive on it or something like that, it raises these interesting legal questions for the future. So. I think it's going to be interesting to have some space folks talking about these kinds of things at South by, possibilities for the future. So you told me a little bit about what you guys are going to be doing at South by, and you mentioned, you do these kinds of things all the time. So what about what you do on a day-to-day basis at the Institute?
So I actually split my time between two jobs at the Institute. I spent my career as a software engineer writing astronomy software for astronomers to use and calibrate their data, or to do whatever they're doing. And so I spent 30 years of my career doing that. But I've always had an interest in public outreach, and I've always had a sort of a foot in the door with doing astronomy planetarium shows or whatever. And so after the Institute noticed my YouTube channel, which is called Deep Astronomy, and they saw how many subscribers it had, they wanted to use my experience at the Institute to expand our social media stuff. So I spend half my time doing social media outreach, and we are doing it for not just Hubble, but we're also responsible for helping with James Webb, as well as WFIRST and the test missions as well. So we're doing outreach for a lot of different multi-mission support coming up. So that's how I spend my day.
Could you tell me a little bit, you mentioned Hubble and Webb, James Webb, and then WFIRST. Could you kind of give me a little bit of an outline of all three of those telescopes, like where their capabilities lie and those kinds of things?
Well, the beauty of Hubble is that it's got a much wider wavelength range than any of the other telescopes. If you want, for example, ultraviolet wavelength exposures, Hubble's the only game in town. You can't get ultraviolet images from any other telescope. It's not astronomy you can do on the ground. It requires space telescope. And Hubble has filters that do ultraviolet. They also do optical and the near infrared. So it's got a much wider wavelength range, and that's why it sort of captured our imaginations for so long. It was able to take these beautiful optical wavelength photographs, and that's why we've become used to seeing all these great images from Hubble. But the real astronomy, to do real astronomy from a science perspective, it's all in the infrared and the longer wavelengths. And so almost all future telescopes are going to be in the infrared for that reason. The reason is that, you know, the universe is expanding, things are redshifting into those wavelengths, and that, if you want to study old galaxies, early stars, that kinds of things, you need the infrared. And so that's why all these telescopes are being built that way. The Webb Space Telescope is primarily, it is an infrared telescope. And it goes into a much wider infrared range. It also is many times bigger than Hubble. So the resolution, so the resolution it can see and how far back into the universe it can see is much greater than what Hubble can do. So it's a bigger next generation Hubble that is designed to expand on what Hubble's built. It's going to be able to see, the Webb Space Telescope is going to be able to see the very first galaxies ever formed, the very first stars ever formed. It will be able to resolve individual planets around other stars. So it's going to have a lot more capability than Hubble. And finally, WFIRST is much further down the road. In the 2020s, it's going to go up. It's the same size as Hubble because it uses one of those donated NRO, National Reconnaissance Office telescopes. It was donated to NASA. So it's the same size as Hubble, but it was designed to look down at the ground instead of out into space like Hubble is. So, but it's going to have a much, much wider field of view. Imagine looking at the sky through a straw versus looking at it through an oatmeal box or an oatmeal tube or something like that. It's going to have a much wider field of view, which means we're going to see more of the sky at once and be able to it's called a survey telescope for that reason. So we can look at lots of stars, supernovae, things like that. So WFIRST is coming down the road a little bit much later. It's only just now. It's still being designed, actually.
One thing I'm really looking forward to with WFIRST is its ability to do wide field survey deep field images, because the Hubble deep field was so significant, particularly to you. So could you tell me a little bit about that?
So deep fields are an important part of Hubble's history. I'll never forget it. I was still in college when the first Hubble deep field came out, and I didn't think much of it when I first saw it. It was just a bunch of smudges and smears in a black square. But then I learned how it was taken, and basically they went out of their way. Hubble astronomers did, to look at an area of sky where they knew there was nothing. There were no stars, there were no gas and galaxies, nothing between, there was just a blank area of sky, and they just stared at it for 11 days. That was actually risky, and they saw an image full of galaxies. And once I appreciated what that meant, I was forever changed by that. I mean, I was never the same again, no matter where you look. And it's been proven. It's now being shown, because Hubble is currently doing a program called Frontier Fields, where they're doing that 6 more times in 6 different areas of the sky, and they're finding that, they're trying to answer the question, well, are there Hubble deep fields everywhere you look? Is there like that everywhere in the sky?
Yeah.
And they're finding that it's pretty. There's a lot of galaxies out there.
Well, what was it? Einstein said that. His work basically said that the universe is not just homogeneous but isotropic. So it would have to be. The distribution of matter and energy is fairly even across everything. And Kobe map and W map, the things that saw the afterglow of light being able to permeate the universe. We've kind of colloquially called the afterglow of the Big Bang. That's not quite accurate, but it's easier to understand. So we'll go with it. Those have shown that we should see deep fields everywhere. And so that was a prediction that was made, and it's nice to see that we're able to predict things that actually come true, that, hey, we actually do. We say, hey, there are deep fields everywhere, or we should find them. Oh, wow, there actually are. And there are likely trillions and trillions and trillions of other planets out there, too, which is really interesting. Makes Anakin's line from Star Wars, I want to go see them all, just a little bit too difficult to actually pull off.
A little bit impractical.
Yeah, ever so slightly. When, like you were saying, the Hubble's been up there for 25 years, so it's just a little bit younger than me. But so how is Hubble feeling, being 25, turning 25, being a quarter century old? If it could talk, what would it tell us about how it's feeling right now?
It's feeling great. I mean, there's that last servicing mission really was a rejuvenation. It was on its last leg. before. Many of there are some critical components to Hubble that just wear out. One of them are these things called, these are the gyroscopes. Those are I believe there's 5 of them or 6 of them. The Hubble needs those to be able to point accurately. If they fail, then Hubble can't point very well. They use that nominally, using 2 at a time or 3 at a time. They don't use them all at once because they don't want to wear them all out. So they kind of rotate them on a schedule. I think one of them has died, but they've got plenty right now, and the other ones are working great. The momentum wheels are running well. Momentum wheels are these big wheels that spin that actually move the entire telescope around. The cameras themselves they've put in brand new detectors, so they're fresh and ready to go, and they're doing real well. They do degrade over time, but they're doing well. So I think if Hubble could talk, he'd say, "I'm doing great. I'm doing awesome. Let me at it."
It's funny how we have kind of anthropomorphized the Hubble Space Telescope. Sometimes I wonder whether or not it's because it sees in the area of light that we see that we've become so attached to it, and the fact that humans have been able to go to it and things like that.
Well, I think it's that, and also the fact that Hubble has done more to show us our place in the universe more than I think any other thing we've ever built. And next to going into space and stepping on other celestial bodies, I think looking at these distant galaxies, looking at these nebulae and star-forming regions that Hubble has shown us, it humbles us, and it's an emotional connection. So we've connected emotionally to Hubble because of what it's taught us. You look at some of these images and you just get overwhelmed by what they mean. And so it's easy to get emotionally attached. And when you're emotionally attached to something, you anthropomorphize it, you make it your pet, you do all kinds of things. So that's my theory on why Hubble has come to mean so much.
Yeah. Definitely. No, I guess it's a good thing we've made it our pet, because it has made us take such good care of it over the years, and it's done such valuable scientific work. I read somewhere that more scientific papers have been published using data from the Hubble than any other scientific instrument ever built in history. We're almost out of the promised allotted time, so I want to say thanks, Tony, for giving me this preview about South by and what the Space Telescope Institute is going to be doing there and going to be involved. I will see you there.
Yes, we'll be live streaming from there.
People. So, yeah.
So we'll be there. And so as far as I just want to make a quick comment on South by attendees. They have been overwhelmingly supportive of everything we've done the past couple of years, and we look forward to seeing them this year with some Hubble 25th content and materials. So please stop by, and thanks for all your support over the last couple of years. It's been really wonderful.
And cheers to the Hubble huggers.
Cheers to the Hubble huggers. I know I'm the leading Hubble hugger.
All right, Tony. Well, thank you for talking to me, and I'll see you in the spring.
All right, I'll see you, Carl. Thank you.
Bye.